operations.
Hello everyone, this is Socrates Kartakis, an MLOps specialist for AWS. In the last few videos, we covered the theory of MLOps regarding people, process and technologies. In this video, I will show you how you can implement MLOps on AWS. Specifically, we will see again the architecture designs, but this time we will deep dive on the different services that you need to use. And I will share also key code repositories in order to be able to implement everything by yourself. But let's deep dive. Before we move on to the different services and the architecture designs, it is really important to share with you the key tenets that I use whenever I architect a solution and a key platform, let's say, an MLOps platform. The first tenet that we need to use is the platform needs to be flexible. That means, data scientists, they want to use completely different libraries for completely different use cases and completely different frameworks. That means that we need to be able to support all of this. Then we need to ensure reproducibility. As we saw in the previous few videos, we will work in a multi-account scenario that we need somehow to be able to reproduce the different executions on building the different models. So we need to support this. The next one is about reusability. And reusability is a key and very important aspect in MLOps in order to improve speed to value. That means whatever we build, all the artifacts, the code, the source code, the notebooks needs to be reusable as key modules. Then we will talk about scalability. Scalability is not only about increasing the number of instances or increasing the size of instances. It is also the ability to use different services, different libraries, different solutions, and incorporate those into our own platform. The next one is about auditability. This is very key, especially for enterprise customers, that they need to know how they created the models, what data they used in order to ensure data privacy. So we need to make sure that we keep all the lineage of all the different executions. The next is about consistency. As we already said, we work in a multi-account scenario, in a multi-account setup, in a multi-environment setup. That means that all the different environments, they need to be consistent in order to make sure that whatever we move to production is robust. And last is about to be secure. That means that we start with deny all permissions. That means nobody has access to anything. And we start building step by step all the different policies and permissions for all the different infrastructure code that we will see. And of course, we don't need to have internet to make sure that the data stays in our own private cloud. But let's check, based on the maturity model, the different steps. Let's start with experimentation. In experimentation, as we covered last time, we have the data scientists that they create their own notebooks and they have some snapshot of data in a local bucket that they are able to start building the solutions. In this scenario here, what we introduce is an AWS account. This box, this black box, represents an AWS account. Okay? Then, in order to store the data, we have this key service that we call it S3 bucket. S3 bucket is a place that we store the different files. It is like a file system on the cloud. And we have now the data scientists that they need to build their notebooks. Most of the times, whenever we will talk about machine learning, we will talk a lot about SageMaker. SageMaker provides a very key service in order to enable data scientists to start building their own notebooks. And this is SageMaker Studio. But what is SageMaker Studio? SageMaker Studio is an IDE that enables data scientists to have their own space, their own file system, their own data, their own notebooks, and be able to implement everything. Now, normally what is happening whenever you have a big Jupyter notebook server, all the data scientists, they used to operate in the same server and all of them to have access to everything. As you can imagine, if something wrong happens, then the server goes down, then all of them, they cannot operate. So with SageMaker Studio, what we have is different data scientists. They have their own environment with their own data, as we said already, and their own notebooks. And they are able to implement their solutions independently of the others. And it is very simple to change the instance type, the machine that they want to run their own algorithms. Specifically, SageMaker Studio has a simple drop-down menu that the data scientist can select from a GPU machine to a CPU machine by just clicking a button. As you can imagine, this is very important. Otherwise, what you have to do is to shut down the server, start a new instance with the new requirements, with a new size, and then have all the data scientists to start working on this. Within few seconds, you can have the same in Studio. But how can we set up a studio, a SageMaker Studio? In order to set up SageMaker Studio, the only thing that you need is to define a SageMaker Studio domain. A SageMaker Studio domain is nothing else than a set of IAM policies and rules that says SageMaker Studio will have access to these different services. For example, Lambda, Glue, depending what the data science wants to use, or to the specific bucket that we have on the local account. After we have set up the SageMaker Studio domain, the next step is to set up also a user account. That means that each data scientist will have its own user, for example, data scientist Socrates, data scientist John, and with that way you are able also to manage in what resources these users will have access. Now, we have set up Studio, we have set up the accounts, the data scientists are ready to start implementing the solutions. One of the key services that we have in order to start checking and track the experiment results is SageMaker Experiments. SageMaker Experiments, to put it simple, it is just a centralized place that you can store all the different metrics from all the different executions that you conduct, from training, from processing, from all the different steps that you want. The only thing that you need to do is to register your metric and to push the value and the different values. Now, not only you are able to store all the different metrics and the values of the metrics, but you can also create visualization dashboards, and the data scientists are able to see the history of these metrics. Very powerful service for experimentation phase. But enough with experimentation. Let's move on a little bit to see how we can implement such a secure environment. In this slide, I shared with you one of the artifacts that I shared with most of my customers of how to create a secure SageMaker Studio environment. This example here that you can see at the bottom of the slide contains the code that tells you how to set up the studio domain, how to set up the different VPC endpoints. What are these VPC endpoints? These VPC endpoints tell you internally in your own private cloud how the different services will interact. That means that if you don't have VPC endpoints, the traffic will go to the internet. In that case, with a VPC endpoint, the traffic stays inside your private cloud. But let's see a little bit the key services that you need in general to implement solutions. Of course, you need everything around SageMaker. Then you need also everything around buckets and repositories. You need access to the encryption keys. You need access to the different IAM roles and policies, and also some key examples that you need, some key services that you need is around ECR, that you store all your custom containers, and code artifact in case that you want to store all your libraries locally to your environment. And lastly, you need also Service Catalog. Service Catalog is a very powerful service because it allows you with a simple way to define products, and then from the console or automatically you are able to define the different parameters of this product, and this will deploy CloudFormation stacks into your accounts. Service Catalog does not support only CloudFormation, it currently supports also Terraform and CDK. So the key services that we saw in experimentation environment and the initial phase. These are SageMaker Studio and SageMaker Experiments. But let's move on from experimentation to the first MLOps phase, that is the repeatable phase. In the previous video, we saw that we need to move from the world of notebooks to the world of automation and to create ML pipelines, workflows that they do pre-processing, training, post-processing. How can we create these automatic pipelines, these automatic workflows on AWS? First of all, we need to define all the different Lego blocks that this workflow has. That means that pre-processing, training, post-processing steps, somehow we need to run our own algorithm. How can we achieve that? SageMaker provides Amazon SageMaker processing. Amazon SageMaker processing is nothing else than managed containers that allows the data scientist to say, I want to run in this instance, this algorithm with these inputs and outputs on S3. But let's see that in more details. Here on the left-hand side, I have an example code of how you can create a specific processing job. The only thing that you need to do is just to define what type of instance and what type of container you want to use in order to run your code. Then the next step is to run this processing job. Over there you define first the code that you want to run, the inputs and outputs that you want to use. Then by running this code that, as you can see, it is just 2 lines of code. It is not like, let's say, using custom containers, Kubernetes clusters, or other type of containers, or ECS, ECR, Fargate in order to do everything. By running these 2 lines of code, what SageMaker will do is it will get the data from S3, it will create the container, it will move the data inside the container, it will execute the code, and it will return the results back to S3. As you can imagine, this is very, very easy for the data scientist to use rather than having pure containers. SageMaker supports predefined containers. That means that we have containers that we have sklearn libraries already implemented, already deployed inside, but also SageMaker supports managed clusters. That means that you don't need just to have a simple container to run your code, but you can create a PySpark, a Spark processing job, and to run your PySpark code. This is very useful whenever you have a large amount of data. And for all these predefined containers that we have, we support all the key frameworks that your data scientists really need. But if you are an expert user and if you want to bring your own container, this is supported. The only thing that you need to do is to move the container inside ECR, and from there you are able to use it. Up to this point, we have defined one Lego block, the pre-processing step, let's say. But let's imagine that we have multiple steps, we have defined all these multiple steps, and we need to link all of them together to create the ML pipelines. SageMaker has the service of Amazon SageMaker pipelines that is nothing else than a service that helps you to create these ML pipelines. SageMaker pipelines, they support specific type of steps like pre-processing, training, tuning, hyperparameter optimization with other words, Lambda steps, EMR steps, or even callback steps that you are able to call any type of service you want. But how can we create such a workflow? The first thing that we need to do is to define the processing steps with a similar code as the previous slide that I showed you. That means that first you need to define the type of the processing job. Then you need to create a processing step and to link it with, and to link your processing job with this processing step. Then the only thing that you need to do in this processing step is to define the input and outputs and the code that you want to run. After you have defined all these different steps and the training steps that you need, the next step is to link all the steps together. How? The only thing that you need to do is to send all the different steps that you have defined in a single list. This is the first very powerful feature that SageMaker Pipeline supports. Instead of being responsible to design the complete graph that we see here, the right-hand side, SageMaker detects all the dependencies of inputs and outputs of all the different steps and creates this graph with the most optimal way for you. What I mean is, let's imagine that we have a step that it has some inputs let's imagine that we have a step that has some inputs directly from S3. That means that this step does not depend on the outputs of other steps. That means that this step will run at the beginning together with all the steps that they don't have dependencies. Let's imagine now that we have a step that depends on the output of another step. That means that this will run in a different level and in parallel with all the similar steps. With that way, SageMaker pipelines make sure that you have always the most optimal graph. Now, another very important benefit. This service is for free. That means that you don't need to pay per execution per execution of a SageMaker pipeline. The only thing that you need to pay is whatever you execute in every single step. And lastly, a key benefit. SageMaker pipelines are very well integrated with all the different SageMaker components and tools that the data scientists can use to create ML use cases. One more note. Probably someone might say, oh, you have very specific steps that you support. Yes, but trust me, these steps are more than enough for the data scientists to build their own solutions. Of course, if you want to integrate a different service, use a callback step. It is always available. Up to this point, we have defined all the different Lego blocks. We have created the ML pipelines using SageMaker pipelines. These SageMaker pipelines are responsible to do pre-processing, training, post-processing, and to create a model. Somewhere we need to be able to store this model with all the different metadata. This capability is around model registry, as we saw in the past. SageMaker has released the SageMaker model registry that is responsible to act as a centralized place to store all the models, the metadata of the model, the containers of the models, and all the activities with the models. Let's talk about this in more details. Model registry is a place that you can store the model artifact, that is the model.r.gz, and specifically the S3 location where you store it. You are able to store all the different objective metrics. For example, I want to track the mean square error. I want to track precision or recall. So you are able to store all the performance metrics. You are able to store metrics like who has created this particular model and the status of the model. Has someone approved this model to go to production? SageMaker Model Registry supports also to push custom metadata. Now, on top of the metadata, SageMaker supports to store the container that we use to train the models. Why? Because later on we need the same container to deploy the model in order to make sure that all the necessary dependencies are in place. Lastly, from SageMaker Model Registry, we are able to change the status of the model. By using this blue button at the upper right corner, we're able to approve or reject a model to go to production. Another capability of Model Registry is that it creates all the different versions automatically. That means every time that you push a model into Model Registry, it will create a new version, it will store new metadata, it will store all the necessary information from the new version, and then you will be able also to track the performance and benchmark the different versions of the model. But let's see now, okay, we have processing jobs, ML pipelines, SageMaker pipelines, model registry, how everything is linked together in order to build a project. In the previous video, we saw an example of how we structure a project, but here I will show you with AWS services. First of all, what you need is a repository. In AWS, with this symbol, we mention code commit, AWS code commit. AWS code commit is nothing else than the repositories on AWS. In this repository, what we need to store is the code of processing jobs and SageMaker pipelines. Then every time that we push into the main branch, what will happen is this will trigger a CI/CD pipeline. In AWS, we have a service that we call it AWS Code Pipelines. These are the CI/CD pipelines that we support. What this CI/CD pipeline needs to do is to get the code, validate the code, run different tests, create custom containers if it is necessary, deploy the SageMaker pipeline, and start the execution of the SageMaker pipeline. The SageMaker pipeline will do the pre-processing, training, post-processing, and it will send a model into model registry, and model registry will create the new version of the specific model. And for model deployment, we have another repository, the model deploy repository, as we already saw, that we store all the code of what we want to deploy, how we want to deploy the model. We have different ways to deploy a model that we will see in the next few slides, but one of the most common ones is to create a server and to host the model inside the server and to be able to start getting requests and return predictions back. We call it SageMaker endpoints. A SageMaker endpoint is nothing else than multiple instances behind the scenes that they host the model, they get requests, and they return the results back. Why I say multiple instances? Because we want to scale massively. If you have a customer that they want to have millions of predictions per second, then you need to have multiple instances behind the scenes. So, in the model deploy repository, what we store is the code of how we can build a SageMaker endpoint, how we can test a SageMaker endpoint, and also some configuration of this endpoint. How can we trigger now and to get the code from the model deploy and start executing the deployment process? From the model registry. From the model registry, every time that we press the update status that I showed you earlier, and we approve the model, this will trigger an event bridge event. This event bridge event will trigger a CI/CD pipeline that will start the deployment process. In the deployment process, the first thing that our code in the model deploy repository will do is to deploy an endpoint. For example, here, it will run the different tests and it will wait for a manual approval. After the successful manual approval, this will deploy a new endpoint into production. At this stage, it is not necessary to use code commit or code pipelines in order to build the projects. You can use any kind of service you want. This might be, I have seen many customers that they do a combination of Bitbucket and Jenkins, other customers GitLab and GitLab Actions, depending on what you prefer to use. But the methodology and the whole structure is exactly the same. Now, what SageMaker said is, in order to build such a project, it requires effort. Why? Because you need to instantiate repositories, CI/CD pipelines, model registry, event bridge events, probably buckets behind the scenes. And they said somehow we need to help data scientists in order to instantiate such an environment with a simple click. So that's why in Amazon SageMaker, we have the Amazon SageMaker projects. Amazon SageMaker project is nothing else than service catalog products that with a simple click deploys the whole infrastructure for your data scientists. They can get parameters like the name of the use case, and it will create all the infrastructure based on this as a prefix, based on how you prefer and how you have set up everything. SageMaker supports 7 predefined templates. One of these templates is the one that I showed you here on the slide, but also it has the capability to allow you to build your own custom project template. This is extremely powerful, and with most of the customers, what we do is we create such a SageMaker project template, such a custom SageMaker project template, depending on their needs and depending on their tools. Behind the scenes, what you need to create is just a service catalog product with specific tags that will be visible by SageMaker Studio in order to allow data scientists to use it. An example of such a custom project template in terms of the seed code, the example code that we used to add in the model build repository is here. So in this example, what we provide in the custom project template is the code that implements all this SageMaker pipeline. This SageMaker pipeline has, for example, as a first step, the data sampling, different pre-processing steps like one-hot encoding or drop different columns. Then we have data quality checks. Then we can have model training or hyperparameter optimization. Then we can have evaluation of the models to run some inference and to see if the model can generalize, or we can generate also some baseline statistics that we will see later on that will be very useful for the monitoring process. And we can do some post-processing, like convert the probabilities to something meaningful, and we can create a model and send this model to model registry. As you can imagine, if you create now your own SageMaker custom project template with this example code for your data scientists or ML engineers, the only thing that they need to do in order to create a new production-ready solution is to instantiate the project, add a couple of new steps into this SageMaker pipeline, configure the pipeline with the right way, and have the first version of the production-ready solution up and running immediately. This is a great boost for your development process. And in the previous video, as a recap, we saw also an example of how we can structure the different repositories, the seed code of the model build and model deploy repository that you need to standardize in order to make the development even faster. For example, as a quick recap, we have three folders: the notebooks, the ML pipelines, and the algorithms. Algorithms contains the code of all the processing jobs, training jobs, etc. ML pipelines contains the code of the SageMaker pipeline, and the notebooks contains the origin of the solution. From model deploy repository, what we have is the code to create the SageMaker endpoints, the configuration in terms of staging and production, application infrastructure code as well. This folder is very important whenever you want to have other services to call the endpoint. For example, you have an API gateway that all the different users will use in order to interact with the endpoint, and behind the scenes a Lambda function to trigger the endpoint. All this code should go there. Or you can have other code about scheduling the batch inference, for example, so you can have event bridge over there. And you need to have another test folder that over there you can store all the different tests like unit test, integration test, thread test, or other tests that you might need to use. So, recap, very important, SageMaker project templates to create your own custom one. You can templatize the most common solution, the most common ML use case that you have across your business, and then your data science and ML engineers with a simple click, they don't start from scratch, but they have a baseline solution they can start tailoring and having a real new solution into production extremely fast. Up to this point, what we saw is just that all the data scientists, they need to create their own feature branch, create their own step, the new step or the new configuration, and push all the changes to the main branch in order to deploy a SageMaker pipeline. Sometimes the data scientists, they want to test the pipeline before during the feature branch development before they push it to the main branch. How is this possible? In this single branch development strategy, they need to leverage other solutions like local testing of SageMaker pipelines, that is a capability that the SageMaker pipelines supports. Or in best case scenario, they want a system that every time that they create their own feature branch, they're able to create a feature version of the SageMaker pipeline. How is this possible? This requires a little bit of additional development. More or less what we need to do in order to achieve that, every time that we create a new feature branch or development branch, we need to create also a new CST pipeline that will get the code from this feature branch, and it will create a feature version of this SageMaker pipeline. And then in the model registry, we need to have another model group in order to store all these models. For more details, because this is a very difficult topic, you can also access this source code and also a blog post as well. It has a reference to a blog post that shows you how you can instantiate a new CST pipeline and a new SageMaker pipeline based on a multi-branch development strategy. Up to this point, we have just one AWS account for experimentation. We have the SageMaker Studio domain and the user setup here. We have the bucket to get the data, and we have a repository to store our code. The next step is to have multiple accounts. Why we need multiple accounts? In the previous video, we said that we want to separate the concerns. In the lower part of this diagram, what we have is the world of data engineers. Most of the times, the data engineers, they need to have a centralized place to store all the different data from on-premise or other data sources that they call it data lake. This data lake has its own account. For some more larger, let's say, customers and enterprise customers, they might have multiple data lakes that, very briefly, they might call it data mesh approach. We are not going to cover this now, but keep in your mind that a customer might have multiple data lakes. So in this environment, what we have is the data engineers to ingest the data from on-premise into buckets into the data lake. This will trigger ETL pipelines that will create the historical data for the data scientists. That means that we will have multiple joins from multiple data sources. And the data engineers, what they will do is will send a snapshot of data from the data lake inside the experimentation account in order to enable the data scientists to start experimenting. The data scientists, they start experimenting in SageMaker Studio, they create their notebooks, they are able also to share notebooks among them. And after they are ready and they have proved that the solution works, they go and they discuss this with the lead data scientist. If the lead data scientist approves this solution to go to production, what he does is just to instantiate the SageMaker project. And what is happening behind the scenes, as we saw already, by instantiating a SageMaker project, this will create a number of CI/CD pipelines and repositories that the ML engineers and the data scientists, they start working together. The code that they write inside these repositories is related to create SageMaker pipelines and processing jobs, as you can see here, to do automatically pre-processing, training, and post-processing. Now, at this point, it is good to say that the data engineers, they need to send input data or historical data into the development account in order to feed the SageMaker pipelines with new historical data to train new models. As I already mentioned, this is a separate account, the dev account. Why is that? Because at this point we place a line and we say experimentation account might be a more relaxed account that the data science, they have access to synthesized data, anonymized data, and they might have access to internet. But the dev account is a place that the production begins. That means that nobody has access to do manual operations. Everything should happen and all the deployments through CI/CD pipelines. And in some cases, you might need also a SageMaker Studio domain into the dev account just to check the results of the execution inside the local bucket. Now, the models that the SageMaker pipelines use to produce, they need to go to model registry. Model registry is close also to ECR. Why? Because we need to store also the containers. As you can see here, I use a completely separate account for all the repositories, CI/CD pipelines, and model registry. Why is that? Because later on we will see that we need a centralized place for all the different teams to start pushing the models over there in order to be easier to audit the solutions. And more or less, if you take that differently, at the lower level over there, we have the data layer. In the middle part here, we have the computational layer. And at the upper part there, we have the place for all the different artifacts. It is well structured and well organized. Now, sometimes if we have the dev account and the experimentation account to have access exactly to the same data and exactly the same people that have access to build the solutions, sometimes we used to link or to have to consolidate these two accounts into one. Also, sometimes for smaller companies that they want, let's say, to have less accounts, we can consolidate the tooling account, the dev account, and the experimentation account into one. But later on, we will see if you have multiple teams that you want isolation and auditing, this is not a good practice. Up to this point, what we saw is during experimentation, we have SageMaker Studio and experiments. In model build and in repeatable phase, we have processing pipelines, model registry, and some default project templates. Let's see what is happening with the automation of model test and model deploy and the governance as well. After we have built now the data lake over there, the experimentation dev account and the tooling account, the next step is to introduce a new account, the pre-production account or staging account. This account is responsible to simulate the production environment. How do we trigger now different models to go into pre-production? From the model registry. The approvers that we have here, they're responsible to approve the right model, model version 3, for example, to go to production. This will trigger a CI/CD pipeline and it will deploy, for example, in real-time use cases, a SageMaker endpoint. Then it will run the different tests that we have in the model deploy repository. And after tests like unit tests, we have covered that already in the previous video, integration test, stress test, and end-to-end test, what will happen is this will move to the stage of the manual approval before we move everything to a new account, the production account. Over there, we have again the approvers to approve, to check the results of the automatic tests and approve if the model can go into production. Why do we need now two different accounts, the pre-prod and prod? Let's imagine that we have the pre-production account merged with the dev account. What will happen in that case, in the dev account, because we want to do development, we have more IAM roles and policies. That means that if we simulate the deployment of the endpoint inside, let's say, combined dev and pre-prod, this breaks the consistency and this breaks the robustness. Why? Because in production, that is a more restrictive environment, we might not have the same IAM, we don't have the same IAM roles and policies. So we need to separate the dev from prod. Why do we need to separate the pre-prod from prod? Because we don't want the testing process to interfere with the serving process. In the production environment, we have an endpoint that other users will start using here, right? And get predictions back. Let's imagine that you can hit a hard limit, right? Or a soft limit on AWS. That means that you cannot have as many executions as you want or as many resources as you want. In that case, you will have losses in terms of requests that we don't want to have this. That's why we need to separate the two processes of testing and serving over there. These two environments, production and pre-production, are completely isolated environments. That means that nobody has access to do any manual operation, even to access these environments. Most of the times what we used to do is also to return the results from production environment in case that we have batch use cases back to the data lake. That means that instead of accessing production environment to test or to check what is happening with the inference results, you need only to check what is happening into the data lake. And this is reasonable because in that case, you have all the data together in a single place and not into multiple accounts. That is very difficult to observe. What we run in production, we covered that earlier. We have deployment guardrails. That means that you deploy the new version of the endpoint, for example. Does it work? Yes or no? If it works, then I can bring the new endpoint up and running. Or you can just replace immediately the endpoint. We have data and model monitoring that we will cover in the next few slides. We have A/B testing and shadow testing. But let's see some of these testing mechanisms. The first one is the shadow testing. That is one of the new services that was released in the last reInvent 2022. What normally happens is we have an application over there that sends some requests into an endpoint, into a specific version of a model that we have into production, and then the endpoint and the model will return the results back to the application. This is one variant of the model. Let's say that we want to have a shadow variant. SageMaker supports to create your own shadow variants and to conduct tests. How can you conduct tests over there? So what is happening is the application, when it sends the requests, it goes to the one variant that is already the production ready one. And the SageMaker will send the request to the shadow variant as well. The difference is, instead of sending the responses back to the application, the shadow variant sends the response back to an S3 bucket. With that way, the data scientists and ML engineers, they are able to go into this bucket and to check the performance of the shadow variant. Very important service to make sure that everything is robust and your model performs well before you productionize that. Up to this point, we talked a lot about real time. right? And we talked about real-time endpoints. That means that we deploy the model in a server or in multiple servers, and it gets a request and returns the results immediately back. That means that you need to have always a machine up and running in order to get requests. And this is very good solution whenever you have, let's say, multiple customers that they log into your website and you want to, for example, to return back personalized results and to get predictions like this. But what if you don't want to have always up and running an instance? One of the solutions that we provide is the serverless inference. In the serverless inference, you send a request. At that time, the model will start getting the request, start some processing behind the scenes, like Lambda, and it will return the results back to you. That means that we have zero scaling here. You don't need to have a machine up and running the whole time, but you use it only whenever it is necessary. Of course, this has some limitations. These limitations are related to let's say the type of machine that you can have, only CPU based, for example. It has some specific timeout requirements and some cold start issues. Now, this is very good solution whenever you cannot really predict when you can have an inference request and when this inference request is not quite frequent as well. Now, in most of the use cases that most of the customers used to have is related to bots. For example, if you do churn prediction, right? What you do is every 3 months you train a model, and every month you run for all your customers if they will churn or not churn in order to get your predictions. That means that you need to pass a massive amount of data, the data of all your customers, into the model and to get the predictions back. This is the case that you need to use a batch approach. In the batch approach, we support the batch transform jobs. In batch transform jobs, what you can say is, I have my data into this S3 bucket, right? Use the latest approved model into model registry and return for me back the predictions to S3. Then SageMaker does everything automatically behind the scenes. It starts the machines that they are necessary. It will run all the predictions and it will return the results back. Very powerful to have batch transform jobs. And some customers also, they create SageMaker pipelines that they do pre-processing, batch transform, post-processing in order to create this solution. We have also another category, the micro batches. In that case, we have customers that they want to send some few images, let's say, from a machine for predictive maintenance, not in huge size, but in a medium size, and to get some predictions back. In that case, we support the asynchronous inference. What SageMaker supports is you can send the data to S3 and again to get the results from S3. The difference between batch and micro batch is the size of the data that you can use and the type of applications. Now, a very big topic that we have in machine learning is how you can monitor your models. Let's see the flow. The first thing that we saw that we do is we use historical data in order to train models. And then what we do is we move the models into model registry and we deploy these models as SageMaker endpoints, for example, into production. Somehow, in order to test and to monitor what is happening with the models over there, we need to check the behavior of the data. How can we achieve that? SageMaker provides the capability of SageMaker Monitor. SageMaker Monitor, the first capability that it has is that you can pass the input features of your historical data into SageMaker Monitor, and this will create the training features, baseline statistics. What are these baseline statistics? These baseline statistics, they are, for example, min, max, average of each column of your historical data and the distribution that this data used to follow. This is just a JSON file that is an output, but you can store that inside a bucket, or you can store that inside the model registry as custom metadata. With that way, in model registry, you have everything, even the behavior of your input features of the specific model that you train with this data. Okay, up to this point, we have captured the behavior of the input data that we use to train a model. In production, the endpoint receives some input data requests. That means just a row of data, and it returns back a prediction, a probability. It does not make sense to run the monitoring for one row of data and one output. Why? Because more or less you need to check the distributions of the data. That means that somehow you need to store the data into inference results table. Into this inference results table, what we store is the input features that we got as an input data and the predictions that we got from the endpoint. Now, after we have collected a number of data, right, like 1000 records, now it starts to make sense to check and to monitor the behavior of this data against the data that we use to train a model. That means that more or less we need to schedule the monitoring job to run every time that we have enough data. And this is how SageMaker Monitor can help us on the other hand side. From SageMaker Monitor, you are able to schedule a job, and what it does, it can take the input features from the inference results, it will translate those into baseline statistics for these inference results input features, and it will compare these baseline statistics with the baseline statistics of the data, of the input features of the data that we use to train a model. With that way, by comparing the statistics and the distributions of the data, you are able to raise data drifts. SageMaker Model Monitor allows you to set the different thresholds that you need in order to make that more strict or less strict. But up to this point, we saw the behavior of the input data. That's why we named that also data drift. We have also, we need at some point to check the output and the behavior of the model itself. How we can do that? With exactly the same way. The only difference is, in order to produce the baseline statistics, we use both the input and the target. So the input and the output. We generate the baseline statistics, we send them to the same place, and then for the inference results, we check both the input features and the predictions, and we send this to the monitoring job. This will help us to generate model drifts and to detect model drifts. So data drift notion is about checking the behavior of the input data. The model drift notion is checking the input and outputs of the models and the behavior of the data. Where we have what? All this generation of the baseline statistics during training should happen into the development. Now, the monitoring is a process that happens into production. One more example, we don't support only monitoring for real-time endpoints, but also we support the same flow for batch use cases. As we saw in the previous slide, we need to generate the baseline statistics. This is exactly the same process. But then what we have is a batch transform job to do the batch inference. What you can pass to the batch transform jobs is, first of all, the model that you want to run the predictions, the data, the batch input data, and then it produces the results. Now, on top of these inputs and outputs that you can define, you can also define the location of the baseline statistics, and you can say if you want to monitor everything before or after predictions. This behind the scenes will activate the SageMaker monitor that will be able to generate the data or model drift alarms. Then you are able also to, by the way, to link all these detections with event bridge events or with an email and to send this to a data scientist. Very quickly also, another important service, SageMaker lineage tracking. You can enable that and it will capture the journey of the data and the artifacts in order to produce a model. And then very easily you can run also some queries in order to check what data you used in order to produce a specific model. Now, another capability that was released recently, back in reInvent 2022, was the ML governance feature of model cards. Model cards is a way for non-data scientists or business people or auditors to get, let's say, the view of a model and what is the performance of the model. The first thing that an ML solution owner needs to do in order to create a model card that will capture data is to define the ML problem. So as you can imagine, imagine that the owner can go to the console, create a new model card from SageMaker console, and the first thing that they need to fill is what is the purpose of this ML use case, and pure English, the description, what we need. Then later on, what we can do is from the notebooks or from the automation, we can translate the data science metrics into business metrics and start pushing these details into model cards. These metrics are related to the whole life cycle of a model. For example, you can send metrics from the data, from the model building, model evaluation, and model deployment. And all this information goes into a centralized model card. And this detail is not data science, let's say, related information. It is more business. And the key feature that the model card has is that you can export this as a PDF report for your business stakeholders and your auditors as well. How handy is this? You have the data scientists, they work on their own environment, and the ML engineers, the automation, they produce all the metrics that will be translated and pushed to the model cards, and then everyone can check what the performance of the ML use cases, either from an ML perspective or a business perspective. Now, another very important feature that was released was model dashboards. The need for all the customers is to have a centralized place, a single view that they are able to see all the different models that we have in a specific AWS account, and to check if there is a model drift, data drift, any alert, or if it is an endpoint up and running or not. So in the model dashboard, what we have is a single page at the SageMaker console that retrieves data from SageMaker models. So you are able to see in the specific account all the different models. It retrieves data from the model card, and one of these is the risk rating. This is during the phase that you describe in English what is the ML use case and what you want to solve. And then it retrieves data from SageMaker model monitor related to model or data drifts. And you can see here that you are able to see that you have scheduled monitoring for all these models. For some of them, you haven't set any schedule, and for some of them, you have alerts and when this alert happened. One service that I didn't cover in this video is about SageMaker Clarify. SageMaker Clarify works with similar way as SageMaker Monitor, but is responsible for bias detection, feature attribution, drift detection, etc. It is mostly around explainability. We can cover this in a different video. And the last thing that it gets data is from SageMaker lineage tracking. You are able also to visualize the lineage of your data that you used in order to produce a specific model. This is very important for the ML governance perspective, and more or less it helps you to build this ML control tower that I used to say. Up to this point, what we saw is that we have for experimentation studio and SageMaker studio and experiments, model build, we have SageMaker processing, pipelines, model registry, and projects. For model testing and deployment, we have the real-time endpoints, batch transform, or other deployment methods, shadow testing, and model monitor. And we saw also for model governance that we have the model cards and the model dashboards. Let's move on now to the last phase of the scalable phase. So up to this point, what we have is one team that they are using all these different accounts for all the different stages of development in order to produce a set of machine learning use cases. Now let's imagine that we have 30 different teams or 10 different teams, And all of them, they have access to complete different data, to complete different data science teams. So they need a complete different set of accounts. That's why we create another AWS account for the platform team that we store the infrastructure code for all these accounts here. Then the platform team is able to instantiate a new set of accounts, deploy exactly the same infrastructure code to this new set of accounts, and link the right data scientists of the new team and the right data of the new team to the right accounts. This account here, I call it Advanced Analytics Governance account, but platform team already has a shared service account. This might be exactly the same account. You don't need to instantiate new accounts. Now, about this, someone might say, oh, we have so many different accounts. If I have, let's say, multiple teams, I need to have multiple sets of accounts. What is the best strategy, and when do I need a new set of accounts, or when can I host an ML use case in an existing set of accounts? And this is the answer that I will give you with this diagram here. So in order to decide if you need a new set of accounts, you need to answer 3 key questions. The new ML use case that I want to create, does it use the same data of an existing set of accounts? Is this the same data science team that will implement the solution? And is the same product owner who pays the bill exactly the same? If the answer is yes, then you host the ML use case in an existing set of accounts. If you have a no answer at some point, you need to create a new set of accounts. And let me give you some examples. Let's say that you have the financial team that they do the churn prediction and they have access to all this financial data. And you have another team that does predictive maintenance. That means that this team has access to pictures, for example, from your machines. They don't need to have access to the financial data. In that case, you need to have 2 different set of accounts. And let's imagine, okay, the 2 different teams, they have 2 different data science teams as well. Now, about the last piece, about the billing part. Why it is important to separate a little bit the set of accounts? Because in big organizations, in big enterprises, what you have is different product owners to be responsible for the budget of their team. That means it is much easier for you to calculate the cost if you isolate them based on the accounts. By the way, SageMaker supports automatic tagging. That means whatever belongs in a specific SageMaker domain, it will be auto-tagged and you will be able to check the amount of money that you spend over there. But because you spend more money to other components like the networking layer, it is a very good approach to separate the concerns. There is another also solution that we can have in order to host an ML use case in an existing set of accounts. This is the multi-domain feature that SageMaker Studio supports. That means that at the beginning I said a studio domain is just a set of IAM roles and policies that tells to the data science where they have access, and also that we will support the auto-tagging mechanism under each domain. If let's say you have the same team and you want to isolate the use case of one sub-team and another sub-team of data scientists, then you can create a new domain. This new domain, you can give access to specific bucket as well. That means now the 2 different teams, they will have access to the domains that they need in order to implement the solutions. With that way, you can even reduce the number of accounts that you need to instantiate. For example, for some customers, small customers, that they want to have a type of isolation, right? But they don't want to have hundreds of AWS accounts. What they can do is they create just a single set of dev, pre-prod, prod, and to have all these accounts to be used by all the data scientist teams in order to productionize solutions. And how you separate all these data science teams? By using different SageMaker Studio domains. There are some limits of the number of the domains, but these are soft limits and you can increase them accordingly. The complete set of AWS services that we saw so far in experimentation, SageMaker Studio, and experiments, model build, we have processing, pipelines, model registry projects. In model testing and deployment, we have the real-time endpoints, batch transform jobs, auto testing, model monitor. In governance, we have the model cards and model dashboards. And for platform now, we have the custom project templates, because for multi-account setups, you need to create your own custom project template, and AWS Service Catalog, that is a service that can help the platform team to deploy the same infrastructure code to all the different accounts. In the data side, from SageMaker, you can have a SageMaker Data Wrangler, that is a way to pre-process the data, or Feature Store that we will cover in another video. And you can have also the different data lake specific services like Lake Formation, Glue, EMR, that we can cover also in another video. Here I give you an example from a real repository, right, that you can find here, how the infrastructure code that the different platform teams needs to deploy for the different data science teams. Here you can see that we have the dev, pre-prod, prod. For all these accounts, we need a different VPC, right? Each VPC will have also private and public subnets and multiple availability zones for availability purpose. Now, what we normally do is we have a different VPC per account because they need to have access to different services. You can host all these accounts under the same VPC, but it does not give you the flexibility to tailor the number of VPC endpoints that you need to create. That's why here we have in the development environment a VPC that has all these necessary endpoints for the development. In pre-production and production, we need a smaller set of VPC endpoints because the only thing that we need to do is to get data from S3 and to make predictions if it is batch as well. On top of the VPC endpoints that we need per account, for example, in development, we need for KMS, for CloudWatch, for code commit, for SageMaker ECR, we need also to define the key user roles per account. In pre-prod and prod, as we mentioned, you don't need to have users to access those accounts. So here what we define is just an admin role that have access to everything, a lead data scientist and data scientist that they have access to the dev account in order to do the development. And the difference between data scientists and lead data scientists, like lead data scientists, they are able to instantiate new projects and new resources. A similar example, the previous example that I showed you and the repository is based on CDK for infrastructure as code. And another example that you can use that does exactly the same thing based on CloudFormation is this one. So feel free to follow this blog post that has also the source code of how to build an MLOps platform based on CloudFormation. And here is also another example of a custom SageMaker project template. So you can get this link, and what this implements the multi-account deployment setup. That means that it has example code for model build, model deploy, the model build repository deploy SageMaker pipelines. We can see that here the dev account is consolidated with experimentation account. And then what we see is for the model deployment, from the model registry, the CST pipeline first deploys an endpoint into the dev account just for manual test, and then it continues to the pre-production and production as well. So this is an example of a customer that they wanted just a smaller set of accounts and an easier way to go to production. You can reuse exactly the same to build your own secure MLOps platform very, very easily. And also here we have the Advanced Analytics Governance account that tells you how you can send all these custom project templates to the different accounts that you might want to use. Very powerful folder. Check also the SageMaker custom project template folder. This one has also code for Terraform. And it has also another example of how you can create a custom project template by using, for example, GitLab and GitLab Actions. You can use exactly the same logic of this particular repository in order to integrate, for example, Jenkins and Bitbucket, or to integrate any kind of CI/CD or repository tool for you. As a summary, we saw the different people and processes again, and we land into this architecture design that might look huge, but is the most robust, secure environment for enterprise customer. Depending on your maturity, depending on your size, you don't need all these components and you can do different changes. But if you use that as a skeleton of the key capabilities that you need under MLOps, then I can make you sure that you are able to build a very robust MLOps environment. For example, use the same infrastructure, the same architecture by consolidating dev, experimentation, and tooling account, or use the same architecture by having just one set of accounts. It still works. What you need to have is to have a way to experiment, a way to productionize solutions, a way to store your artifacts, and to get your data securely. But for data scientists, the life is much easier because they don't need to care about all this architecture. The only thing that they need to care is about SageMaker, because from SageMaker Studio, they're able to conduct all the different processes. And this is what we will see in the next video. We will see a real demo how to use SageMaker, SageMaker Studio, and all the different components that we presented today. Key material that I suggest you to check. You can check, for example, the documentation and the main page of the SageMaker. Check the MLOps Foundation Roadmap for Enterprises blog post. This is a blog post that describes also everything that we presented today, including links to the different repositories. And the last one is a repository about the multi-account secure MLOps environment, source code based on CDK. Up to this point, we have reached a very good checkpoint. Why is that? Because we have covered the theory of people, process, and technology, and we saw how you can implement an MLOps platform on AWS and all the key services that you need to incorporate. In the next few videos, what I will show you is some real demos about how everything looks like from a data science perspective, and I will show you how you can set up an engagement in order to build an MLOps platform by yourself. Until then, stay tuned.